I'm Craig Stewart. I'm the primary investigator for Jetstream, and my colleague here is Dave Hancock.
Oh, welcome. I'm the technical lead for Jetstream, and we hope to give you a quick overview of the allocations process, Jetstream, and a little bit about XSEDE if you're not familiar today.
And also one of our presenters, but off camera, is Jeremy Fisher, who's a senior lead working on the Jetstream system. So, to plunge ahead and talk a little bit about Jetstream. Jetstream is a computing resource funded by the National Science Foundation for people who don't necessarily need supercomputers. And for those of us who are closer to my age than Dave Hancock's age, we can remember back to the 1980s when the National Science Foundation first began the supercomputer programs. And since the 80s, the NSF has always done a really superb job of funding supercomputers that are really great at providing thousands of processor cores for batch jobs, particularly if what you want to do is just run batch job after batch job, sort of always iteratively next week. Well, the question becomes now in the middle of the second decade of this century, what does the NSF do for you if you need something other than supercomputers? Starting in 2014, the National Science Foundation began funding a number of novel computing resources, some data-centric, some interactive, and Jetstream is one of those novel new computing resources, and we want to acknowledge with great gratitude the funding that we received from the National Science Foundation through award ACI 1445604 to run Jetstream. And it is part of the answer from the NSF. What does it do for researchers who need something other than a supercomputer? Let me briefly talk about what is Jetstream and why does it exist. It is the National Science Foundation's first production cloud facility. That is the first cloud facility that the NSF has where it's expected to simply work like any other cloud resource on behalf of a biologist, a sociologist, an engineer, an earth scientist, an observational astronomer, anyone who wants to use a cloud-like environment to do their analysis and do that interactively. That's the target audience for Jetstream. And the whole fundamental idea for Jetstream is if you have computing needs that go beyond what you can do on your desktop machine or your laptop, and yet you don't need thousands of processors, Jetstream lets you do the data analysis and simulation that you want to do when you want to do it interactively in real time. So Jetstream provides on-demand interactive computing and analysis capabilities in a cloud environment, and it's intended to be highly user-friendly. The idea is that you log into Jetstream, and the first thing you see, or one of the first things you see in Jetstream, is a list of pre-configured virtual machines. Now, personally, I love living in my own little world. Everybody in my own little world knows me. And what Jetstream does is create for each user your own little virtual world. And we have this set of programs that's set for biologists, for earth scientists, all these disciplines we've talked about to do particular tasks that are relevant to particular disciplines or particular subdisciplines. So we've got this library of pre-configured virtual machines, and we have also base virtual machine images with CentOS and Ubuntu Linux in particular that allow you to create a virtual machine that has your software, your neighbor's software, software that you think is particularly important to you, but we don't already have available in Jetstream. Whatever you want to do, if you can do it inside a VM in a cloud environment, Jetstream will let you do that. Jetstream also supports data movement and access. It's, of course, very important that you be able to get your data into and out of Jetstream. We do that with Globus Transfer, which I believe is really the state of the art in point-to-point data movement within the U.S. There's also a really interesting facility that Jetstream and Indiana University provide in response to user requests. So if you do a set of analyses with a virtual machine and you want to somehow save a record of the work that you've done, we enable you to take a virtual machine, the software that's in the VM, your input data, your output data, and create a binary object that you then upload to Indiana University's persistent digital repository and attach a DOI, a digital object identifier, to that, so that you can actually do analysis for a paper that you publish. You can submit your manuscript to the journals you want to send it to, and you can cite a DOI that has all it takes for someone to replicate your research work as part of your papers, and then people can then download that VM and repeat what you've done. Also, we won't talk about this very much today, but through Jetstream, we provide access to virtual desktops so that students and researchers at schools that are very limited in terms of their local cyber infrastructure can use Jetstream essentially through a tablet device, through a Samsung or an Apple iPad or something like that. This is just a snippet of some of the listings of virtual machines that are available through the Jetstream system. So BioLinux 8 is there. There's a CentOS and Ubuntu base operating system image. R, if you want to use the very, very, very popular statistical package R, it's available. Galaxy, a very popular and widely used bioinformatics workflow tool. There are dozens of these images that are available for you to look at, select from, and also, if you wish, add to, so that your software can be out there and made available to other users of the Jetstream system. Just to give you a sense of what it looks like when you begin using Jetstream, this is the Jetstream web interface. It lets you browse help resources. It lets you see what resources you're currently using. Most importantly, the basic web interface for Jetstream will let you launch a new instance of a virtual machine, see what your existing VM instances are doing, and if you want, add or subtract resources from things that you're doing, or kill off VMs. Jetstream is built with the same conceptual approach that commercial cloud providers use for their cloud resources. We have 3 physical locations that are involved in housing parts of the Jetstream system. There is a test system that is at the University of Arizona. We are using the OpenStack cloud software environment. So each time a new version of OpenStack comes out, Jetstream is tested and debugged on this test system at the University of Arizona. And then we have 2 production systems that are essentially identical. One operating at the Texas Advanced Computing Center in beautiful Austin, Texas. The other operating at the Pervasive Technology Institute at Indiana University in equally beautiful Bloomington, Indiana. And between these 2 systems, which have redundant connections to Internet 2 and the XSEDE network, Jetstream is almost never down. Our goal is for Jetstream to be up 24 hours a day, 365 days a year. So whenever you want to compute, you can log into Jetstream and compute. We talk about Jetstream being a managed science cloud. That is a cloud that's managed for science. And this is the thing that makes Jetstream different than, say, commercial cloud providers. It's smaller than commercial cloud systems, but scientists and science students and engineers are the intended market. We build Jetstream and we optimize it to support scientific research. And we've got a list on our slide here of major target disciplines: life sciences, biology in particular, other than protein folders. If you're a protein folder, you probably already know about the NSF-funded supercomputers anyway. Earth sciences, engineering, economics, sociology, observational astronomy, all the sort of places that need more computing than comes easily in a desktop machine without needing thousands of processors in a supercomputer. Now, I want to talk a little bit about something called the Extreme Science and Engineering Discovery Environment, and I want to introduce a term called Cyberinfrastructure. So the NSF very broadly supports cyber infrastructure, which we define as consisting of computing systems, data systems, instruments, networks, and people all linked together to improve research productivity and enable breakthroughs that are not otherwise possible without use of cyber infrastructure. XSEDE is the most heavily funded, largest grant award given out by the National Science Foundation to support cyber infrastructure delivery and use throughout the U.S. XSEDE stands for the Extreme Science and Engineering Discovery Environment. And if you have never heard of XSEDE, you may well be the type of researcher or student that we are targeting as a future user of Jetstream. Now, you do have to go through XSEDE to request time and resources on Jetstream, and XSEDE, XSEDE.org is where you go to create a portal account and request an account and time on Jetstream. But the Jetstream name was chosen purposefully with the existing and future NSF-funded infrastructure in mind, as an analogy to the jet stream in the atmosphere. In the atmosphere, the jet stream is a body of rapidly moving air that is at the boundary of two very large masses of air in the upper atmosphere. And the idea behind the Jetstream Cloud system is that it operates at the boundary between existing NSF-funded cyber infrastructure supported and allocated through XSEDE and new users who have not in the past made use of the NSF-funded cyber infrastructure. So we'll talk about XSEDE several times here, but the key issue, I think, for you as a potential Jetstream user to know is that XSEDE will help you use Jetstream. XSEDE is the vehicle through which you request resources on Jetstream. And with that, I'm going to turn the floor and the slides over to Dave Hancock. Dave.
Yeah, thanks a lot. So we're going to first touch on a little bit of overview, and then we'll walk into a video that essentially takes you through the application process. There are different types of allocations for XSEDE. We're not going to cover the startup and educational allocations, so they are available. They have a rapid turnaround, usually 1 to 2 business days. There's a getting started video on the Jetstream website that's under 5 minutes. If you want to get started with those type of allocations, I'd encourage you to watch that video, and we'll point out where it is in just a moment. We are focusing on the larger research allocations, and the next submission window opens the 15th of March and is open for a month. Those awards would start at the 1st of July. And if you do receive an allocation in that time period, it would be good for 1 year, and they would encourage XSEDE that you would apply in the same window the following year for a renewal. If you run out of resources before then, you can also request a supplement. But we're going to focus on that first research allocation request. There's a lot of good background material, and I would encourage you to do some of the reading and follow the links in this presentation and some of the highlights we'll have. So you have your homework ready, you have your supporting documentation ready. You don't have to do it all at once, but just an awareness of what you have to put together and not waiting till the very last day of the cycle to start doing this. And one of the things that's particularly critical in this process is ensuring that the resources you're requesting are well justified, that you do have a good scaling document that you can show. Now, my application does scale to these type of resources. It doesn't have to be on an existing XSEDE resource. It can be on something comparable. It can be on a commercial resource, just showing that you have something comparable, especially for a cloud environment. It's a lot more flexible than the traditional HPC resources where you're running very, very large scale jobs. So what makes good documentation? Really just following the allocation policies. If you've already submitted NSF proposals in the past or are an NSF-funded researcher, those documents and those formats should comply. They do request that when you upload documentation, and we'll show that in the video, that those are PDF documents, not Word docs or LaTeX documents or whatever. Your CV is preferred to be in an NSF or NIH mini bio format, and those are typically 2 pages. And the main document, where you're essentially describing your work and what you're going to be doing, should be no more than 10 pages. And if you're requesting over 10 million SUs, then it can be up to 15 pages. Additionally, there's a separate scaling document that you can refer to in the main doc that's up to 5 pages. Some of the highlights that XSEDE suggests is that the research is being summarized in the current context of state-of-the-art in whatever field, how you're using computational algorithms to solve your research problems and justify your request, and provide good, sufficient detail, but not trying to overwhelm them in the minutia and all the details of your request. Making sure it's clear and very much coupled with the experiments you want to run. And so if they do need for some reason to make a reduction, because the XSEDE process is typically oversubscribed, although it's a little easier to get on Jetstream now since it is new. There's a process by which they can say, well, if we give them a portion of the request, they can still do a lot of the research. And if you have been a part of a previous allocation, making sure that those manuscripts, documents, or publications are uploaded in the XSEDE portal, and any progress documents or anything are also part of the request. But again, that's not our focus. We're looking at more first-time requesters in this process. Some other details of note: you don't have to do it all at once. Sit down in a flurry and submit all these within an hour. You can pause and come back to this process. You can upload part of the documents, save it, get the process started, and come back and edit it over the period of a few weeks. The types of VMs Jetstream provides will help with those scaling calculations, so I'll show a link to that. The bottom line is 1 service unit on Jetstream is equivalent to 1 virtual CPU hour. We're using Haswell processors for comparison with other resources. That's the same as what you'll find on Chameleon and some of the Cloud Lab resources, as well as some of the Amazon resources as well. And we do have hyper-threading enabled, so all that is factored into your calculation. And the platform is really ideal not only for this interactive use on demand of small-scale research, but also for Science Gateway hosting, for hosting a community as a front door, or for programmatic use of Jetstream. Since it is a cloud, we have OpenStack APIs and other APIs enabled, so you can tie those into your Science Gateway and use it to burst onto Jetstream and provide resources to an entire community. And that's something we've done with a number of gateways to date. And finally, one of the things as part of the request, you can request help either from the extended collaborative support services within XSEDE, gateway development staff, to help with your research optimization, with development tasks, and especially if you're just starting out and you have a little bit of development resources to do this. This can be a supplement and an assist to work alongside you to continue that progress. And then lastly, before we get to the various web pages and the walkthrough video, if you do have questions either throughout this and can't use chat, feel free to send a note to help@xsede.org or help@jetstreamcloud.org. They both route to us. There's a lot of documents on our wiki, and that's also linked from the primary website, jetstream-cloud.org. And many funded and unfunded partners have made this possible in conjunction with the National Science Foundation. So we'll switch gears here. And this first page that we're taking a look at, this is the XSEDE allocations overview. As I mentioned, part of doing your homework, it describes the various types of allocations. If you want even more detail on writing and submitting a successful XSEDE proposal, there's a nice webinar on that topic. It's a little over an hour. I would highly suggest you read through this. There's some examples of educational allocations. And then if you follow this link for sample research allocation requests, you can see both sample scaling documents and main documents that you can use as an example, and they're divided up by field of science. So you can probably find one that's relevant to your work. Then I also talked about the allocation policies page and the preference for NSF formatted documents. This page describes all the detail of the margins, font sizes, page length, all of those required documents. So reading through this, turning it into a checklist as you prepare for your submission is useful. And this is the main Jetstream website, just jetstream-cloud.org. The video I mentioned previously talking about getting started with Jetstream and getting a startup request is this link here. And if you want kind of a starting page and saying, I'm new to XSEDE, you guys should all have XSEDE portal accounts and registering for this webinar, so you're already along the path. But you can follow this step-by-step allocations link, and this will take you over to our allocations page within our wiki and provide that kind of checklist of what you want to have together before you get started, and links to the XSEDE documents as well. So if you want to go one place to start, that's what I would suggest. And we have a link in talking about the scaling document to our VM sizes and configurations. So if you take a peek at that, we'll be adding some other sizes in the near future, but the calculations are fairly straightforward here, where one service unit is one vCPU, so equivalent to the number of tiny VMs you need, and the hours it runs is how you would calculate how many SUs to request. These are similar to a T2.small type instance on Amazon, if you've used that before. And next we'll move into the walkthrough video, and then this will go through the process of actually submitting an allocation in the XSEDE portal. And if you guys have any questions, we'll pause after that and allow you guys to ask some questions. So the first part will be to log in, create an account. If you guys if you have not, most of you on this have. There'll be some announcements as part of the XRAC when it opens any particular note. So it does show the next period, and it'll have a brief checklist of what you should have ready. I think the other references are a little more useful, as it provides more detail. When you go into start, you will search and be able to add people based on their XSEDE user portal credentials, and you can add folks as managers of the allocation or the PI or co-PI of the allocation, and additionally add users. You can always do these do these steps, adding users and things like that later. So there's no need to do all of that up front. If somebody doesn't have an XSEDE portal account, I wouldn't worry about adding them up front and slowing down your submission. This text is just a title and a brief abstract of what you're requesting. The main part and primary request will be in the main document that you'll upload separately a little later as part of the process. Have some keywords, maybe field of science or tools that you're using, and then you can scroll down and find what particular area is the best fit, and this helps direct who on the review panel and what group would be doing that review. To move into the next phase, you'll choose what resources you want to request an allocation on. So if you select Jetstream, you can choose the number of SUs based on that calculation you've done before. You'll want to have done your scaling calculations and check all of those things before you come to this page and submit how many you need. Those fields are optional for the number of IPs, and you can additionally request storage. This is in gigabytes, and you must have a Jetstream computational allocation in order to use a storage allocation. You can't just request storage on Jetstream and not have any computational cycles. They're tied together. As we move into to the bottom section, this is where we talked about extended collaborative support. So if you do have development needs, porting needs, things like that with your software tool set, you can request those services here as part of your request. And I would suggest if this is new for you for the first time, not requesting many person hours, but that quarter of a person or so will be a good starting point. Next page will have you upload your various documents, starting with our CV here, again in that NIH NSF format preferably, the COPI CV, and then we also have uploading a main body document, and that document up to 10 pages for anything under 10 million SUs, and your scaling doc, which is up to 5 pages for either format. And those again should be in PDF format as we're showing here. There are other list of documents that if you did have a progress report or something from a prior allocation, that's where you would upload that here. You'll want to enter your supporting grants, the title, funding agency, grant number. These do not have to be National Science Foundation grants, just whatever is supporting your research. When you put in your program officer, it's not so to get you in trouble and get your award reduced by any means for using XSEDE resources, but it's more of XSEDE's benefit to say, hey, we're supporting this research, and the percentage support there is of your grant, of your work that you're doing that's computationally intensive. What percentage of Jetstream or whatever resource you're using will be supported by that. As you move into the next phase, you'll add any XSEDE related publications. So if you've had prior XSEDE awards, you'll want to make sure that any publications that benefited from those resources are uploaded, and you can either then submit the request, or you can save it for later. And when you come back, you can choose to edit, and you can also choose when you're ready, or think you're ready, you can choose to validate it, make sure everything is complete, and when you're finally ready for the request, go ahead and submit that request. So that's the last part of the video, and we'll open up the floor for any questions. You can feel free to type them in chat, If you have questions later, again, you can send those to help@xsede.org or help@jetstream-cloud.org. And hope this was useful.
Dave, one or two things popped into my head as you were going through that. One of the things I was reminded of is that this allocation process was not designed with Jetstream in mind. The allocation process was designed for supercomputers in a situation where there's probably 3 times as many requests as there are resources available. So if it feels like you're having to spend a lot of time justifying your usage, it's partly because down selecting amongst requests for resources that are chronically oversubscribed is part of the process here. The other part is this is taxpayer money we're spending, so it's good to justify what any of us are doing with NSF money. And one particular part of this, sort of the origins of the allocation process, really has to do with the scaling dock. And in the supercomputer world, it's very common that in any given application, you get to a point where adding processors no longer makes it go faster. So if a computer program runs and completes in the same amount of time with 512 processors as it does in 2056 processors, you run at 512 at a time, and understanding how effectively a given application can use a large supercomputer was the original purpose of the scaling document. For Jetstream, the purpose of the scaling document is to take whatever reference points you have and use those reference points to justify the amount of resource on Jetstream that you're asking for. So it is, asking for Jetstream resources is just a little teeny bit like pushing a square peg into a round hole. But if you understand why you're going through the process like this, and remember that at the end of this, you get to use a really cool cloud system that's designed just for you, it will all be worthwhile. Jetstream's a very exciting system. We're excited to host this resource. We're excited to help you. So are there any other questions?
So actually, I want to open up the floor. Jeremy's answered quite a few questions over chat. One of them that I think is important is that somebody asked if their allocation, if their NSF grant is expiring and has no money left, are they still allowed to apply for an application? Jeremy says yes, there's no grant required at all. And then I'm going to let Jeremy answer a couple of the other technical ones that came into him, just in case people weren't watching the chat window.
Hi there. Can you all hear me? This is Jeremy.
Yep.
Okay, great. So a couple of things came in during the talk, and the first was about the oversubscription, whether it was hyper-threaded cores or physical cores. And the oversubscription is based on hyper-threaded cores. So there are 24 physical cores per node. 2 of those per CPU go to overhead. So basically, you're left with 44 virtual CPUs per node for virtual machines. So that's where those numbers come from. When you look at like the XXL is 44 vCPUs, it's basically using all of the resources on that node. So hopefully that answered that question. There was another question about any plans for GPU-enabled VMs, and it's something we are exploring, and we have no hard dates for saying yes, that's going to happen by this point. But maybe Craig can weigh in on that here in a moment. But right now, there's no firm plans.
Sure, and I'm happy to weigh in, and then let Jeremy get on to other technical questions. When we proposed Jetstream, we knew that to a very real extent we are doing what is for us and for the NSF a system that is both a production system and a first-of-a-kind pilot project. The NSF has never funded anything like this before. There's been tremendous community support for having a resource like this, but we're in uncharted territory. Given that we knew we would be operating in uncharted territory, we decided that we would start with a completely homogeneous system, so every node is identical. and we're doing pretty well at getting the bugs worked out, getting the kinks worked out, getting the system running properly. We would like to add GPU functionality. Doing that requires both an opportunity to ask the NSF for funding, and it requires the NSF having funding to give us for GPUs. So it's definitely in the plan in the category of things that we would like to do, but it requires a new allocation of money from the NSF to do that. Jeremy, back to you.
Okay, and then the last one was a question, is it possible to access VMs with more root volume size per CPU? The answer there is no, and actually what's going to happen is we're in the process of resizing our VMs. There's some technical reasons, and then there's some sort of more cloudy reasons for what we're about to do, and that's actually reducing the root volume size. That said, because of the Jetstream storage allocation, you can actually request volume-based object storage. And it comes down to the thought that VMs are meant to be ephemeral storage. They go away. Volume object storage is meant to be persistent storage. So if you're doing research and you need scratch space or storage space for your results, you want to create a volume using the Jetstream storage allocation and mount that onto your VM. You don't want to keep anything on the central VM itself that you don't expect to go away when you tear it down. So the answer there is more storage to be had. It's not going to be as part of the root partition, though. It'll be a mounted partition.
Other questions?
Jeremy, if you could answer the one that came into the chat just now from J.D. Campbell.
Okay. So figuring out the SUs that you're going to need for an allocation. So that gets to be a sort of trial and error period. So a lot of people use their startup allocation to figure out what they're actually going to need for the research allocation. They'll figure out their scaling and sort of how long it takes on X-sized VM to run. For example, we just had an allocation that they went through and figured out that their runs run better. Their sweet spot is between 6 and 8 virtual CPUs. So they could use a bigger VM, but it's actually going to be not as efficient to do it that way, and that they would be better off using smaller VMs. So a lot of that comes down to, it's not required to have a startup allocation, but it's recommended from the sense of you get a better sense of what you need to move forward sometimes. And we can help you with that as well. Whether you jump directly into the research allocation or whether you want to start with a startup, you can send a ticket in to help, and we can talk about what you're doing and what your needs are and try to help you get a sense of what you should ask for. It differs for every application. It differs for everybody's workflows. So there's really no good single rule of thumb that I can give you. Did that help?
So we do have a question that came over chat. Are there any agreements with commercial software vendors with respect to software licensing?
There are. And that's an excellent question. And the major agreement we have is with MATLAB. So we have MATLAB and the standard first 52 MATLAB toolkits all available on Jetstream. So if you are a person who wants to run using MATLAB or any of the standard first 4 dozen or so MATLAB toolkits, we can fulfill those needs on Jetstream, and you do not need a local license. You don't need your own license where you are. Just log into Jetstream and MATLAB is there. We are hoping that this will be particularly interesting to engineers. We also recognize that there are just a plethora of applications for things like the signal processing toolbox and other toolboxes that are in MATLAB. So MATLAB is the one really big commercial license we have, and I think at this point it's the only sort of general purpose commercial software package we have. We do have
Jeremy is mentioning that we have Intel
We have
compiler.
Yeah, Intel
compiler.
compilers. Yeah, I was looking at Dave, and I was going to ask compiler. So we've got the Intel compiler suite as well.
Yeah, and one of the things you can also do if you do hold a license for something, you can image that in a VM if it's a local license, and keep that private if the license allows. It doesn't have to be shared, or as in the case what we're doing with the Intel license is refer to a license server elsewhere. So you can take that VM and configure it to point to your license server at home, should your local IT policies allow.
And Jeremy, the neuroimaging guy, as he just self-proclaimed, is going to answer a question about how to create a VM for a particular discipline or subdiscipline. Oh, except I might have muted him when I muted all guests. Jeremy, I'm finding you. All right, Jeremy, you're on.
There we go. Yeah, I started talking and I realized that I have a little red mute button next to me. So one of the great things about Jetstream is being able to make your own custom workflow and software environment. So what you can do is what I recommend is start on the smallest instance you can, and there's a technical reason for that. Of once you get to a certain size, you can always launch on a bigger instance than what you started on. You can never go smaller. So if you need to know about the size of your software needs, and then launch the smallest instance you can, install your software, and then on the instance screen in Atmosphere, there's a little button on the side with all of the other start, stop, delete, etc., that says image. And you click that, and it'll walk you through the steps of submitting your instance to be imaged. And what that means is we take your running instance, we make a snapshot of it, we do some cleanup on it, things like home and the root and temp, and some of the XSEDE configuration files are actually removed as part of a safety mechanism. And then it is copied into a fresh image that you can make private just for you. You can share it with explicit team members. You give usernames, or you can make it public for everybody to use. So through that, it's a fairly simple process. Dave is showing the screens on the wiki as I'm talking about it. And that actually will give you a lot of information on it as well. But it's a pretty simple process to do. Typically, the turnaround on getting an image is 24 to 48 hours, and we have it back ready for you to use.
And this is actually maybe a good moment to talk about how important Jetstream can be to researchers who want to disseminate their own software. And I'll tell a very brief tale of two bioinformaticians. Both are colleagues of mine. Both are great biologists. Both are great bioinformaticians. Both are really superb programmers. One is a very good software engineer. The other, no, not a software engineer. With Jetstream virtual machine images as a way to disseminate one's software. If you're a great software engineer, great. If you're not, really, to disseminate your software through Jetstream, all you have to do is get it running once on one VM image and then disseminate it and make it available through Jetstream. You don't have to worry about all the software engineering that goes into taking an application that will run on one operating system on one piece of hardware and make it downloadable and installable. So for the software developers and software creators community, Jetstream is a great way to get your software out where people can get to it and make use of it easily.
All right. Well, thanks for everybody's time today. And if you have follow-up questions, please feel free to send those via email or or visit our wiki, our website, and hope you got something useful from today.
Thank you all very much. Send us an email if questions arise later.